everybody, welcome to this session. Please, first thing, I would like you to scan this QR code. I know it doesn't sound super safe, but please trust me on this one. There is all the content that I'm going to present during those 30 minutes tool in action session. There are going to be the slide, how to rate, and all the links that I'm going to go through during this presentation. Thank you. All right, so what is this session about? Paketo Buildpacks, are they the best way to build container images? This is what we're going to find out. But first, let me introduce myself. I am Anthony Dahanne. I live in Montreal, Canada, and I am a software engineer. Even if I am currently living in Canada, I've been born and raised in France. That would explain my accent, I guess. Recently, I have joined a company named Hero Devs. And at Hero Devs, part of a team, the Java team, who actually works on fixes for vulnerable open source components that are end of life. But also, I am a Paketo Buildpack maintainer. I've been so for a little bit more than 2 years. I'm not going to go in much detail right now because, well, that's the topic of the presentation today. Apart from that, I am also the Montreal Java User Group president, and as such, we organize meetups every month, basically, as well as the Devox for Kids Quebec chapter, where we organize workshops for children every quarter, children aged between 5 and 14 approximately. Okay, let's dive into the presentation. So we're going to discover what are Buildpacks. This is why you are here. And I know your first question is going to be, but Anthony, why should I use Buildpacks since I'm already familiar with Dockerfiles? I'm going to give you some reasons. And you'll see if you're convinced or not. And then we'll see how you can use Buildpacks and where also you can use them. All right, a very high-level overview of a Buildpack. Well, a Buildpack is going to act on some folder, some source folder. Here in this example, we have a pom.xml and an RCRC folder. So what we expect from a Buildpack is to turn the source code into something that can be executed as a process. So in the case of a Java app, probably because we have seen a pom.xml, we expect the project to be compiled, built into a jar, as well as we expect an entry point to start up this application. The process is going to be, performed by a Java Buildpack. There is going to be a first phase of detection. And during this phase of detection, all the Buildpacks, because, I mean, you could say that Java Buildpack is a meta Buildpack that include sub-Buildpacks, for example. All the included Buildpacks are going to evaluate if they can do something with the source code. So, for example, obviously, the Maven Buildpack will detect the pom.xml, and it's going to say, hey, I think I can do something with this pom.xml. And then, once we have evaluated all the Buildpacks that are going to participate, then they are going to start doing their work. They are going to build. For example, the Paketo Buildpack for Buildsoft Liberica is going to download the proper JVM for the project. As well as the Paketo Buildpack for Maven, we expect it to run Maven clean package. And if Maven is not included via the wrapper, probably it will also download Maven for us. Another example is the Spring Boot Buildpack that could actually download a helper library and put it inside the class path. Here in this case, the Spring Cloud Bindings library allows you to read some environment variables, some properties from your environment, and turn them into Spring configuration, for example. Anything is possible. So, where do they come from? When have we seen the Buildpacks first? Let's go back in the past, around 2011. Heroku created the platform as a service. It was a way for developers to basically git push their code to something, to Heroku, and then Heroku would actually detect what is the source code, what to do with it, and then run it, open a port, and expose it. At first, if I remember correctly, it was Ruby on Rails project, but then they extended that to other languages. Few years later, we can see that Heroku continued, as well as Pivotal. Pivotal, at that time, they wanted to create a platform as a service that their customers could run on-premise. And this is when they created the Cloud Foundry project. So they created the Cloud Foundry project, and then they created, of course, the Buildpacks for Cloud Foundry. Fast forward until 2018, and we have the third iteration of the Buildpack that we called V3, as well as Cloud Native Buildpacks. And that was done in collaboration with Pivotal, Heroku, and a few others. It's possible also that this timeline doesn't apply to you. Maybe you have seen other thing that looks like Buildpacks, but it's definitely possible. For example, Nixpacks, if you are familiar with Nix OS, they also have a way to detect some source code and turn it into something executable. And they also support, as far as I know, some Nixpacks for Java, but is being used also by other platform as a service providers. And maybe inside your company, some people, they have already written some shell scripts to detect that there is a pom.xml, and then to actually run the Maven command, right? I've been actually working for a company who actually implemented their own Buildpacks with shell scripts. That was something. Anyways, this is what Buildpacks are for. But from now on, we're going to focus on the third iteration. So this third iteration of Buildpacks, who owns them, basically? At the top, here we can see the Linux Foundation has created the Cloud Native Computing Foundation. They are pretty well known, the CNCF, for Kubernetes, of course, as well as OpenTelemetry and many, many, many other projects, including Buildpacks.io. And what is the responsibility of Buildpacks.io is to basically provide and maintain a CLI to interact with the Buildpacks v3 that we call Pack. This is the Pack CLI. They also have a spec, and they maintain a spec, and also a Go executable that is named the lifecycle, and the lifecycle is basically the binary that knows what to do, that knows how to orchestrate the detection as well as the build phases. Okay, but I mean, all those things, they do not allow you to build Java projects, you might say. This is why there are implementation of Buildpacks, of this specification. The one that we're going to focus on from now on is going to be the Paketo Buildpacks implementation. The Paketo Buildpacks, they support a wide array of languages. Of course, Java, Node.js, .NET, Go, and so on and so forth. This time, though, the Paketo Buildpacks is not under the CNCF, but rather the Cloud Foundry Foundation. On the left, you can see that I have put some notorious corporate contributors. But also, when I created those slides, the first time that I created those slides was to basically explain to the audience that the Buildpacks and the Paketo Buildpacks, they are not owned by a corporation, so that it means that they cannot suddenly change a license model, right? We have seen that many times over the years with HashiCorp and Terraform, or most recently, I think Liquibase also, they changed their license to have a dual license. That's not going to happen with Buildpacks and Paketo Buildpacks because they are under the Linux Foundation. That's fantastic. But then when I reviewed recently the slides, I was like, VMware, which acquired Pivotal, has been essential, has been a key contributor for the Buildpacks along the years. But unfortunately, they stopped doing so, something like since they were acquired 2 years ago, their contribution have been declining. And I think there are no more contributions from VMware anymore. So to be honest, that's kind of a shock, because when you're a maintainer, you're kind of a bit sad that there are less energy put into the project. So as maintainer, we have actually noticed that. Daniel Mikusa wrote this blog post at the beginning of the year saying, you know what, we're still looking for contributors. Maybe we're going to change our approach to open source with the Paketo Buildpacks, and we're going to focus on what matters most. Maybe, like the little build packs that nobody uses, maybe we're not going to maintain them anymore. Maybe we're going to focus on Java, where most people are, and for a good reason, right? Because Spring Boot is using Paketo Buildpacks as a default to build their container images, so that's definitely a great user. And then the story could end there. But you know what? I got something to tell you. 3 weeks ago, Java 25 was out. And as a Paketo maintainer, I said, you know what? I want to volunteer to create the support for Java 25. So for all the distribution that we support, so we support Bellsoft Liberica, Azul Zulu, AWS Coreto, and so on, I decided to do the work and start doing the work 3 weeks ago. But at that time, not all the distributions were ready to ship a Java 25 distribution. So I did most that I could at that time. And then I say, OK, well, there are some missings. And yeah, that's kind of fine. I made the announcement. And then I say, well, sorry for those ones. They're not there yet. And then, of course, life moved on. But you know what happened during that time? I mean, shortly after that, we have seen new contributors come and add support for Java 25 for the distribution that they were interested in, such as this one here. It was the first time he was a first-time contributor, and he created a PR for Microsoft OpenJDK. And then this person, too, they created the support for Eclipse OpenJ9 25. And then, once again, this guy also created the support for GraalVM. What I mean to say is that the community is vibrant. We are honest. We tell you when we have problems. And actually, I think we're pretty resilient, and we are pretty well set for the future. OK, that was me, like the little sentimental part about this, about what happened with Paketo Buildpacks. Now, why? I mean, that's all nice to say this, but you are software developers, so you want to be convinced why Buildpacks are the right fit for you, right? So let's take this example. This is kind of a very basic Dockerfile, but could work actually, where the developer has defined a base image from OpenJDK. Then the developer has copied the jar inside the container image. Then he has exposed some metadata. For example, the port of interest is 8080, entry point java-jar, cmd app-runner.jar. And then the expected result is that after this image is built, when we're going to do a Docker run of this image, we're going to obtain a java-jar. This is fine. I'm pretty sure you all know about this. That's very typical. How would you do this with the build packs? You would use the pack CLI. I mean, pack CLI is the default CLI, but we'll see during the implementation that there are other implementations to actually use the build packs. So you use the pack CLI, fantastic. You call build on it, you give it a name, and then you can choose a builder, or you can use the default builder. In that case here, we said that we want the builder named Paketo Buildpacks /builder noble Java tiny. What is a builder, you may ask? Pretty simple, honestly. It's just a set of stacks, and stacks are basically base images, with default build packs that are attached to it. In that case, we can read from the name of this builder that it's based on Ubuntu Noble, and it's also going to provide support for Java, tiny, meaning that it's going to be Ubuntu Noble with the least packages possible. Probably there won't be a shell inside of it. OK, that's nice. So pack build my app, fantastic. What are we going to get? We're going to get something much more complex than just java.jar. Why? It's because the build packs are going to provide you with some helpers, for example, which are going to compute at runtime the necessary arguments for memory as well as CPU. So we do much more than just running your application with java-jar. So this is my argument number one. You benefit from the maintainer's expertise, and we are very careful choosing the best choices possible. OK, another example. What about custom certificate authority? Well, you've probably, I don't know if you have been working in banks or insurance, Sometimes they decide to run their own certificate authority. That's nice, that's probably a good idea. But the issue is for users and developers, you need to basically accept, you need to trust the certificate authority. And to do that, you need usually to import into your JVM, into your runtime, you need to import a custom CA certificate. With Java, usually you use the key tool, right? And then you import the cert, and then life goes on, everything is fine. What would you do with the Buildpacks? With the pack CLI, you would do something maybe a little bit better, I guess, because here you would basically mount a volume. So here you've got the volume argument, and then you would provide your certs, your custom certs, inside a folder that would be basically exposed to your Buildpack builder. Okay, of course, you're not super impressed. I understand that. But what about in this bank or insurance company? What about another team? And this other team, they do not like Java for a reason. I don't understand why, but maybe. And they prefer writing Go code. And look at what they did, because they went through the exact same issue, right? They needed their Go runtime to understand the custom CA certificate. And they began writing this Dockerfile, and now they have to maintain it over the years. And you know what they could have done in this company? They could have used exactly the same invocation for all teams, for all languages, because the CA certificate Buildpack is going to do the right thing for each language. And this is pretty cool because it's an abstraction so that your developers, they don't know how to do that, basically in their languages. The Buildpacks are going to do that just for them. Okay, what are the other examples that I can give you? SBOM generation, SBOM, software bill of material. Tomorrow I have a talk about this. It's called From Vulnerability to Mastery. So just come to victory, sorry. Come to this talk and I will talk a little bit more about SBOM, but basically it's a list of ingredients of your app. So whenever you create an image, the container image with the Buildpacks, you will have an SBOM that can be downloaded out of it. So that's pretty convenient. And finally, another example, APM, so third-party agents. For example, here I'm talking about Datadog, as well as Dynatrace, or New Relic, and so on and so forth. How can you integrate them, and how can you put their agent inside your image? Pretty easy. You just give the signal via an environment variable that you need them, and then during detection, those Buildpacks, I mean the proper Buildpacks, is going to be downloaded and is going to insert the agent, and then change the runtime, change the entry point command so that the agent will be run at runtime. And as you can see at runtime, you will be able to configure all the configuration. Okay? Okay, it's a tool in action session. Let's have a little example. Here, I just checked out the code from Paketo Buildpacks /samples. It's a convenient project where basically we share for all type of languages different scenarios of building. So here I'm inside the Java Maven folder. Okay. So the first thing that I would do is that I am in the right folder. I would do pack build my app, and then what builder should I use, right? So in that case, what you can do is that you can ask what are the default builders. So you can do pack builder suggest. And then the CLI is going to give you a list of known builders. And this is kind of interesting to see. You will see that Google Container Platform, they have their own builder, Heroku as well. Of course, they are not Paketo because they have their own implementations of the spec. But right under, you will see all the Paketo Buildpacks. Most of them are built on Ubuntu Jammy. But the last one is interesting because it's pretty new. It's coming from Red Hat, and Red Hat, they decided to contribute a builder based on UBI. Of course, you can choose whatever base image you want when you create your own builder. So, to save you some time, I have already made the build because the network can be risky. So this is the command that I did. I said pack build Maven is going to be the name of my image. I decided to use Java 25, of course. We just contributed, so yeah, we're pretty happy to use it. And then here I'm using this builder that is named builder noble Java tiny. Fantastic. So after you run this command, as you can see, you're going through the phase of detection, and during the phase of detection, obviously, we will see Birds of Liberica, Maven, and so on and so forth. And then, for example, here we can see Birds of Liberica is going to be downloaded. It's going to be version 25. Did you notice that I'm using a Mac M4, and it has properly detected that the architecture of my platform is ARM64, so it downloaded the proper build pack. This is kind of new. We introduced that like a year or two ago. And then after that, yeah, you would expect, of course, the Maven build to happen. Okay, standard stuff. And at the end, well, basically, we're going to close the image and have something running. Fantastic. There was another way to do this using the Maven CLI. So let's have a look with Maven, the way it works. So basically, you do a Maven, where are we? There we are. Maven Spring Boot build image, because once again, the Buildpacks and Paketo Buildpacks are directly integrated inside the Spring Boot Maven and Gradle plugin. So this is what we're going to be relying on. So after compilation, resources, and so on, we will soon, normally, after the tests are running, we will see the plugin that is going to detect what to do. The difference with using the Pack CLI is that the plugin is going to reuse the jar that was already built just before. So okay, it's going to include the jar. It's going to here download the builder image. And then as you can see here, we don't have the Maven build pack participating. Once again, it has already been built by Maven previously. And then, of course, the same thing are going to apply. It should be exactly the same build and the same result. Maybe I did something funny here. Oh yeah, something that I haven't told you yet is that here the builder has almost the same name, but it's not exactly the same one. This is my own builder that I created myself. And this builder is not based on Ubuntu. It's based on a distroless. It's based on a distroless distribution. Let's have a look. I created it. It's here on GitHub. And the way I created it basically is just once again, like I told you earlier on, I created a base image. And this time, instead of being based out of Ubuntu, I decided to use ChainGuard Wolfie, which is distroless and guaranteed without any CV. So obviously, the size of the image is going to be much smaller, and the surface of attack is going to be also much smaller. Cool. Let's go to a more ambitious project. So this time, we have already seen that I was able to choose the JVM version. But now I will try to even choose my own Java vendor. So the default is Birds of Liberica. I'm going to use Azul Zulu this time. And also, I'm going to enable the Spring Boot optimizations. They're pretty recent. They were added between last year and this year. And basically, maybe you have already heard about them, about CDS training run or AOT optimizations. So this is what this is about. Basically, during the build, we are going to start the application until all the beans are wired, and then we shut it down and we extract a caching file. So the Buildpacks are going to automate this for you. Imagine if you had to write your own Dockerfile to do this. Well, you could do, but once again, it's going to take some energy for you to do that. And magically, with Buildpacks, we already have done this work for you. OK, let's have a look. So here, the project is from Oliver Drodbaum. He is known at the Spring team for working on Spring Modulate. And this is his pet project, the Resbugs project. OK, and let's have a look at what he did with the build pack. Here, you can see that he has customized, he has created a Buildpacks profile ID in his build, and here he has customized the Buildpacks a lot. First of all, here we can see that we are choosing our own builder, fantastic. We are using Azul Zulu, okay, why not? We have disabled the Spring Cloud binding additions, probably because we don't need it. Here we are setting the version of Java, and here we are setting all the variables, all the environment variables, so that the Spring Boot build pack is going to understand to do the CDS optimization. Okay, let's have a look. So normally, if everything goes fine, we will have. Okay, here you can see actually this Spring Boot project is based on Spring Boot 4 M3, which is Spring Boot 4 is going to be out next month, I believe in November. Okay, so here, I mean, usual stuff. We see many things that are being downloaded, but I would like to bring your attention to something here. Let's see, something is new compared to the other builds, because here we're basically doing the training run of the jar. As you can see here, we are running the application, but it's a limited run to actually create the CDS archive. And thanks to that, we'll have a CDS caching file that's going to be enabled inside our image. And of course, the goal of this is to have an image that starts super fast. For example, here, this is the Spring RESTBugs project is a REST API, but also connects to a database, so it's a pretty big project. It's not just a hello world. It's slightly more than this. If I run it, and if I look at how much it took to run, it took approximately less than a second. Pretty good, right, for a startup, for a Spring Boot startup of a decent app. And you know what? I also built another version of it without any optimization, and we can compare what is the difference. As you can see, we divided by 2 the startup time. So that's pretty cool. And this is the kind of optimization that you got directly with a Spring Boot build pack that is included and open source. Okay, well, that's all nice, right? How can you integrate this into your own pipelines? Well, we have already seen that you can use the Spring Boot Maven and Gradle plugins, okay, and also you've got the documentation of the Spring website to help you out. Guess what? Quarkus, as we've seen a little bit before, we've seen that Red Hat have created a builder based on UBI, and this builder is, of course, targeted at Quarkus builds. So yes, Quarkus, I mean, I haven't used it that much, but I guess it works fine, and you can actually build your Quarkus images using Buildpacks. There are some integration that run natively from Kubernetes, from a project that is named, an open source project named Epineo. Of course, in your CI pipeline, you can use the Buildpacks using GitHub Actions. There's an official GitHub action for Pack, using GitLab CI/CD as well, and Jenkins. Also, there are some platform as a service that actually use Buildpacks for their own build. And if you are more into cloud providers, just know that GCP Cloud Run is relying on Buildpacks, but their own implementation. They're not using Paketo Buildpacks, but their own. And Azure Container Apps, they are actually using Paketo Buildpacks now. They used, I think, to have their own Buildpacks, but they slowly switched over to Paketo. Let's have a look, for example, with Fly.io. I think I have an example somewhere. Yeah, so here, for example, if you know Fly.io, it's a platform as a service, and you can tell them in a fly.toml configuration file how you want it to be built. So instead of providing a Dockerfile, you can tell them, hey, I want you to use this builder, and these are basically the arguments for my build. And of course, as you can see, you can recognize those are environment variables from the Buildpack project. Okay, pretty cool. All right, then, that's the end. I hope you are convinced. If you're not convinced, try them out. just once again take the QR code, try it at home, and yeah, let me know. You can contact me whenever you want. Thank you very much.